This is Unit 7, Test Study Guide, Part 2. Part 1 included topics 1 through 5. This Part 2 will be topics 6 through 8. So let's go ahead and get started. Topic 6 is about rhombus, rhombi, and squares. Okay, so let's look at the first one. So, problem 22. They're telling us that JKLM is a rhombus. They want us to find each angle. Now remember here, that's a right angle. These are right angles here. Important feature. Okay, angle JKL. JKL. This angle is being bisected. So it's 36 and 36, so that's 72 degrees. Now find angle MLK. MLK. Okay, so we need to know what this is and this. So here we have a triangle. So 180 degrees in triangle. This takes out 90, so these two share 90. So 90 minus 36 would give me 54 degrees. This angle's bisected, 54 degrees, so it's 108 degrees. Now, find the measure of JMK. JMK, right here. Okay, so again we know that if this is 90, these two have to add to 90. So again, this must be 90 minus 54, 36, and this is 36. So they said JMK, JMK, 36 degrees. Okay, the measure of angle MJL, MJL, this angle right here. So again, if it's 36, this has to be 54. So that's 54 degrees. Now, angle KNL, KNL, 90 degrees. Okay, so that's your angles. Now, 23. Using JKLM from the previous question, if MN is 20, so MN is 20. Let me see if I can get a different color. So MN here, MN is 20. So this side is 20. And JL is 26. So what that means is that this is 13 and this is 13. So I see, and they want to know JK. Now JK is congruent with ML. It's a rhombus. All sides are congruent. So here, we're looking at a right triangle where we're looking for the hypotenuse. So the two legs, one is 20, the other is 13, and we're looking for the hypotenuse. So we've got 13 squared plus 20 squared is equal to x squared. So now, if we put in our calculator second square root, so what we're going to do, we're going to take the square root of these, so we're going to have x is equal to the square root of 13 squared plus 20 squared. So if we put that in our calculator, second square root of 13 squared plus 20 squared, then we get 23.9. We get 23.9. So what they're asking us for, JK is equal to 23.9 using the Pythagorean theorem. All right, let's look at the next one. So the next one says STUV is a rhombus. Find angle SVU. Angle SVU. So they want us to find this angle here. So if we find this angle, we'll know what that angle is. All right, so here, this diagonal is bisecting this angle. So we're going to set them equal and solve. 9x minus 43 is equal to 5x plus 1. Move the 5x over. So if I move the 5x over, I have 4x minus 43 is equal to 1. Move the 43 to the other side. So I'm going to have 4x is equal to 44. Divide both sides by 4, so x is equal to 11. Okay, Now they want the measure of SVU and the measure of SVU. Now first, so to get that, we're going to work to that. Right here, we've got 5 times 11 is 55, plus 1 is 56. That's 56, and this is congruent to it, so it's 56. So we see the measure of SVU is going to be the same as here, 56 plus 56, 112 degrees. Okay? Now let's look at the next one. So right here, says if ABCD is rhombus, AD is 4x plus 2. DC is 7x minus 13. And BD is 34, BD. So that means this is 17 and this is 17. Okay, then wants to find AE. He wants to find this distance. What's this distance right here? All right, so let's work on that. So we're going to say now that we want to find out what the length of the side is. Now, rhombus, all sides are congruent, so we can set these equal and solve for x and then find the length of a side. So let's say we have 7x minus 13 is equal to 4x plus 2. Move the 4x to the other side. So if we do that, we have 3x minus 13 is equal to 2. Move the 13 to the other side. So 3x is equal to 15. Divide both sides by 3, so x is equal to 5. Okay, so let's find out what side AD is. AD is equal to 4x plus 2, so that's equal to 4 times 5 plus 2. So AD is equal to 22. Okay, so we have a right triangle here. We're looking for any sides the same, so I can find that. So we have a right triangle where this is 22. So we know hypotenuse and we know a leg. So we have, and we're looking for this, AE. So AE squared plus 17 squared is equal to the hypotenuse squared. So if I move the 17 to the other side, 17 squared to the other side, I have AE is equal to 22 squared minus 17 squared. So if I square root of that, okay, that'd be AE. Now, so let's put that in our calculator. So we have second square root of 22, hit the square button, minus 17, hit the square button, hit enter. 13.96, so AE is equal to 14. Okay? Let's go to the next page. Here we have squares. This is a square. WXYZ is a square. Find each angle. So angle WXY. WXY. That's 90 degrees. Angle XZY. XZY. 45 degrees. YXZ. Angle YXZ. 45 degrees. Angle WRZ. WRZ. 90 degrees. Angle XWY. XWY. 45 degrees. Okay. Angles of a square, quite easy. Now it says using this figure from the previous question, if WY is 32, find XY. So WY is 32. So this is 16 and this is 16. The diagonals are congruent, so this is 16 and this is 16. They want us to find XY. So we're looking for the hypotenuse. So we could say that this leg, 16 squared, plus this leg, 16 squared, is equal to the hypotenuse, which we're going to say they're asking us for XY. XY squared. Okay. So now, if we take the square root of both sides, we'll find that XY is equal to, now let's put in our calculator, second square root of 16, hit the square button, plus 16, hit the square button, hit enter. Okay, that gives us 22.6. 22.6. All right. Now, let's go to one that's a favorite with my students, using the distance formula. So it says, determine the most precise classification for quadrilateral ABCD. Is it a parallelogram? Is it a rectangle? Is it a rhombus or a square? They give us some coordinates here. So we've got some kind of a figure here. We don't know exactly what, but we've got A, B, C, D. Now, first thing we're going to do is we're going to check the lengths of all the sides to see if two are congruent and the other two are different but congruent, or see if they're all congruent. So let's start with AB. I'll use the distance formula. AB is equal to the square root of okay, AB. So I've got x2 is 10 minus x1 is 3 squared plus y2 is negative 2 minus y1 is negative 4 squared. So that's equal to the square root of, this is 7 squared plus, here we have positive 4, take away 2 is 2 squared. So that's going to be the square root of 7 squared is 49, plus 2 squared is 4, 53. Okay, now, so we did AB, let's do CD. CD. Okay, square root of C and D. So x2 is 1 minus x1 is 8 squared plus negative 11 minus a negative 9 squared. So that's going to equal the square root of, this is going to be negative 7 squared plus, here this negative, double negative on the 9 is plus 9, so that's going to give me negative 2 when I add them, squared. So you see that's the same as above, square root of 53. Okay, we did A, B, C, D. Now, let's do, we did AB, we did CD, let's do BC. So BC is equal to, BC is equal to the square root of, now we're doing B and C. Alright, so I've got A minus 10 squared plus, I've got negative 9 minus a negative 2 squared, so that's equal to the square root of, this is going to be negative 2 squared plus positive 2 plus a negative 9, negative 7 squared. Same numbers as above, square root of 53. Alright, let's look at the next one then. So we had, so we're looking for AD now. AD. AD is equal to the square root of A and D. So x2 is 1 minus x1 is 3 squared plus negative 11 minus a negative 4 squared. So that's equal to the square root of. Add these together, we get negative 2 squared plus the negative, double negative on the 4 is positive 4, so we add those together, we get negative 7 squared. So as you see, same number, square root of 53. Okay, so what this tells me is this can be one of two things. It can either be a square or it can be a rhombus. Now, for me to tell which one it is, if I look at the diagonals, if I check the lengths of the diagonals, if the diagonals are congruent, it's a square. If the diagonals are not congruent, it's going to be a rhombus. So let's check the diagonals. So let's do AC. So AC, let's see what we have. AC. Okay, so I have 8 minus 3 squared plus negative 9 minus a negative 4 squared. So that's going to be the square root of. This is going to be 5 squared plus, here we're going to have positive 4, so that's negative 5 squared. So that's going to be the square root of 5 squared is 25 plus 25, 50. Okay. Now, let's see if the other diagonal, BD, let's see if it's going to be congruent with 50. So BD is equal to the square root of. So we're doing B and D. So x2 is 1 minus 10 squared plus negative 11 minus a negative 2 squared. So that's going to be the square root of. Here we have negative 9 squared plus. Now here's positive 2, so that's negative 9 squared. So 9 squared is 81 plus 81, 162. Square root of 162. So they're not congruent. So this tells me, without doubt, that this is, they're not congruent, so it's not a square, it's a rhombus. Okay, it's a rhombus. All right, let's move on to question number 29. So on 29 it says, use this figure for these two questions. So it says that if we have these coordinates for B and C, what must be the slope of ED in order for BCDE to be a parallelogram? First thing I want to know, what is the slope of BC? Slope, so that's y2, that's y2 right here, negative 1, minus y1, which is a negative 5, over x2, which is 4, minus x1, which is negative 2. So that's going to give me 5 minus 1 is 4 over 4 plus 2, 6. So 2/3. So this slope is 2/3. Okay. Now, what must be the slope of ED? It's got to be parallel to this. So the slope has to be 2/3. That's a parallelogram. Now, question 30 says, given the coordinates above, what must be the slope of BE in order for BCDE to be a rectangle? Well, if it's a rectangle, it's 90 degrees here, so it has to be perpendicular. So if my slope of BC is 2/3, then a slope perpendicular to that would be the opposite sign, reciprocal. So that's what BE would have to be in order for that to be a rectangle. Okay, let's look at problem number, topic 8, trapezoids, problem number 31. Okay, so here this is a regular trapezoid, non-isosceles trapezoid. The thing we know about the angles in trapezoid is that opposite angles are supplementary. So if they want to know angle Q, I take 180 minus 41. 180 minus 41. So that's going to give me 139 degrees. Now, I want angle S. So I take 180 minus 104, 76 degrees. Okay. Now, 32 is an isosceles trapezoid. Now, the thing we know about an isosceles trapezoid when we talk about angles is that the base angles are congruent. These base angles are congruent. So angle E, now, these are supplementary. So angle E would be 180 minus 117, which would be 63 degrees. So that's 63 degrees. Now, angle F, base angles are congruent, 63 degrees. Angle G, base angles here, 117. Okay? All right, let's go to the next page. All right. 33. It says, find the measure of angle H. This is a trapezoid. Find the measure of angle H. So we know these opposite angles are supplementary. So we're going to say we're going to go ahead and set these equal to 180. So we have 8x minus 2 plus 5x plus 26 equals 180. Now let's gather our like terms. So I've got 13x plus 24, when I add the numbers, equals 180. So I'm going to subtract 24 from both sides. So that tells me that 13x is equal to 156. Divide by 13, divide by 13. So x is equal to 12. Okay, that's x, 12. But they asked me for angle H. Angle H is equal to 8x minus 2. So that's 8 times 12 minus 2. That's 96 minus 2. So angle H then is equal to 94 degrees. Okay, now 34. Find the measure of angle M. Right here, angle M. Okay, so if I find the measure of angle J, subtracted from 180 degrees, I'll have M. So these two, isosceles trapezoid, these two base angles are congruent. So I'm going to say 8x minus 23 is equal to 6x plus 11. So let me get the x's together. I'm going to move the 6x over here. So I've got 2x minus 23 is equal to 11. Move the 23 to the other side. So if I do that, I have 2x is equal to 34. By both sides by 2, so x is equal to 17. Okay, so x is 17. Now, let's find angle J first. Angle J is 8x minus 23. So that's 8 times 17 minus 23. So that's equal to, if I put that in my calculator, I see that that's equal to 113 degrees, angle J. So angle M is equal to 180 minus 113. So angle M is equal to 67 degrees. 67 degrees. Okay, problem 35. Find the measure of angle G right here. So if we find F, G is congruent to it. Now these are opposite angles, so these are supplementary. All right, so we have 4x minus 7 plus 11x minus 8 equals 180. So let's gather like terms. So we're going to have 15x minus 7 eighths 15 equals 180. Add 15 to both sides. So 15x is equal to 195. Divide both sides by 15. So we see that x is equal to 13. Okay, so x is 13. Now, they want to know angle G, so angle F and G are congruent. So let's say that angle G is equal to 11x minus 8. That's 11 times 13 minus 8. So that's going to be 143 minus 8. So angle G is equal to 135 degrees. All right, let's look at 36. So it says WY is 15x minus 2, and XZ is 9x plus 10. Find WY. So this is an isosceles trapezoid. One of the properties of the isosceles trapezoid is that the diagonals are congruent. Now, it's not true for a regular trapezoid, but for isosceles it is. So if they're congruent, let's set them equal. So I have 15x minus 2 is equal to 9x plus 10. Now let me get my x's together. Move the 9x over here. If I do that, I have 6x minus 2 is equal to 10. Move the 2 to the other side. 6x is equal to 12, therefore x is equal to 2. Alright, now they want to find WY. So WY is equal to 15x minus 2. So that's equal to 15 times x is 2 minus 2, so that's equal to 30 minus 2. So we'll say WY is equal to 28 find AB. Alright, so the mid segment is 63. So we know 63 is equal to 5x plus 7 plus 8x minus 11 over 2. Now, divide this by 2, that makes them equivalent. So let's multiply this side times 2 and this side times 2. So 126 is equal to 5x plus 7 plus 8x minus 11. Now let's simplify the left-hand side. 126 is equal to 5 and 8 is 13x minus 4. Well, we add the numbers. So let's add 4 to both sides. So 130 is equal to 13x. So if we divide both sides by 13x is equal to 10. Okay, they said find AB. So AB is equal to 5x plus 7. 5x plus 7. Okay, so that's equal to 5 times 10 plus 7. So AB then is equal to 50 plus 7, 57. Last problem. It says find YZ. Find YZ. Okay, so let's see. So again, similar to what we had before. So we have 5x plus 1 is equal to 2x plus 7 plus 19 divided by 2. That makes them equivalent, because the top and the bottom together are twice as long as the mid segment, so we made them equivalent. So let's multiply this side times 2 and this side times 2. And when we do that, we're doing the whole thing here times 2. Gives me 10x plus 2, when I do the distribution, is equal to 2x plus 7 and 19, 26. Alright, so let me move the 2x over here. That was 10. So if I do that, I've got 8x plus 2 is equal to 26. Move the 2 to the other side, so I have 8x is equal to 24. So x is equal to 3. Okay, so it says find YZ. So YZ is equal to 5x plus 1. So that's equal to 5 times 3 plus 1. So YZ then is equal to 15 plus 1, 16. Okay, that concludes the Unit 7 Test Study Guide. Good luck on your test.